virtual reality, XR training, AR glasses, and mixed reality experiences. If you've spent even a few minutes researching immersive technology for your organization, you've likely already run into a wall of terms that all might sound the same. And if you can't clearly define what XR, VR, AR, and MR mean, and what makes each unique, it becomes really hard to brainstorm which one can solve your training problems, pitch a project involving any of them, or find the right vendor to build your solution. So, in this video, we're going to define each of these terms clearly, no jargon. And the examples we're showing aren't from entertainment or games, they're real use cases of each technology. We are Roundtable Learning, and we're a full-stack learning company who builds training applications like these for the Fortune 500. And we want you to see exactly what each of these modalities looks like in practice. So we're pulling back the curtain to show how organizations of all kinds are actually using these technologies to train and develop their workforces. Now, before we break down VR, AR, and MR individually, you need to understand the term that sits above all of them, XR. XR stands for Extended Reality. It's the umbrella term for any technology that blends digital content with the physical world to create immersive, interactive, simulation-based experiences. VR, AR, and MR are all technologies that live underneath this umbrella. XR categorically works so well for training because it taps into something fundamentally human. Experiences. For example, reading about how to handle an emergency doesn't write neural pathways with nearly the same intensity as actually going through an emergency. This is why, for the right use cases, learners retain information faster, recall more, and perform better after learning with XR. Beyond learning science even, the practical benefits of XR stack up fast as well. Dangerous environments become safe to practice in because they only exist digitally, and high-stakes scenarios carry no real-world consequences. The training can be delivered to thousands of employees across multiple locations without travel costs, limits of trainer availability, or bottlenecks on real equipment or locations. And because XR can simulate everything from technical procedures all the way to social interactions, it covers a much wider range of training needs than most organizations realize. But here's an important distinction. Not every XR technology is the right fit for every training problem. VR, AR, and MR each have unique features, and picking the wrong one doesn't just mean a subpar learning experience. It means wasted budget, wasted development time, and a training program your employees ultimately won't use. So let's get clear on what each term actually means and what a real implemented version of that term looks like. First up, VR, or virtual reality. VR places the learner inside a fully computer-generated environment that completely replaces the physical world around them. You put on a headset, and everything you see, hear, and interact with is digital. It's the most immersive option in the XR category. There are two main formats VR can take. The first is called 6DoF, which stands for 6 degrees of freedom. In 6DoF VR, you have the most agency and input. You can physically move around the environment and interact with virtual objects using controllers or hand tracking. The second format of VR is 360 video, where a real-world environment has been captured on camera and converted so you can look everywhere from inside the scene. It's immersive, but it's more of a passive experience. You're in a fixed position, observing a scenario play out, and the interactions are more likely to be pointing and clicking at things that you can see. Whether 6DoF or 360 video, VR is the right choice when the training requires the learner to feel fully present in an environment, especially when that environment hasn't been built yet, is too dangerous for learners, or is too expensive to recreate physically. And one thing that surprises a lot of people is how wide the range of scenarios that VR can simulate. Take warehouse operations. We've built VR training for specialized product packing, where employees practice exact procedures, handle exceptions, and learn quality standards inside a fully simulated workstation. No real inventory consumed, no production line interrupted, and no limit on how many times those learners can repeat a step until it sticks. We've also built VR for something much broader in scope, installing various pieces of internet equipment in a residential neighborhood. A technician in training puts on the headset and walks into a simulated home, works through the installation process, troubleshoots various connection issues, and practices customer interactions, all before ever setting foot in a real customer's house. And then there's virtual driving training, where a learner sits behind the wheel of a truck, navigating busy intersections and practicing parking. The simulation puts them in real traffic scenarios, forces some split-second decisions, and builds the muscle memory and spatial awareness that only comes from experience. And it does all of that without a single real vehicle, a real road, or any real risk. 3 completely different industries. 3 completely different training problems. 1 technology that handles all of them, because the core need is the same. Put the learner inside an environment and let them experience it. Now, let's talk about AR, Augmented Reality. AR keeps the learner fully grounded in the real world. Instead of replacing the environment, it adds a digital layer on top of it. Instructions, animations, diagrams, and 3D models appear floating over real objects and equipment, viewed through a phone, a tablet, or a pair of smart glasses. AR works best when the task itself takes place in the physical world, and pulling the learner out of that context would actually undermine the training. For example, if someone needs to understand how a system works in a workshop, AR can place that system right in front of them. Here's a good example of what that looks like in practice. We've built AR learning applications that render mechanical systems as 3-dimensional models that are anchored in the learner's real space. Depending on the training goal, these models can appear at a scaled-down size for easier comprehension, or at a full 1-to-1 scale so the learner develops an accurate understanding of what they're working with in the field. What makes this particularly powerful for learning is that AR can easily isolate specific systems from the rest of the machine. You can peel away surrounding components, focus entirely on one mechanism, inspect it from any angle, and understand how it moves and functions. With a real physical object, that's simply not possible or practical. One person in a classroom cannot disassemble an engine block just to see fuel lines or electrical wiring. You can't scale real objects down for a big picture perspective, or scale them up to study a component that's too small to examine with the naked eye. Except with AR, you can do all of those things. The learners build genuine spatial and mechanical understanding without disassembling real equipment, without stopping a production environment, and without needing to be in a specific location to do it. That brings us to the third technology, MR, or mixed reality. MR sits right between VR and AR. Like augmented reality, the learner stays in the real world. But unlike the static nature of AR content, digital objects in mixed reality don't just appear as a visual overlay, they actually respond to interactions in the physical environment. You can reach out and manipulate them. They respond to your inputs, and they behave like real objects because the technology understands the physical space you're in. That distinction matters more than it might seem. The difference between simply viewing a static 3D model and actually manipulating it is a next-level learning capability. Let's talk about a real project that shows exactly why that matters. We've developed an MR training assistant for new hires who are learning how to operate powered industrial trucks inside of large, active warehouses. Learners wear smart glasses that display interactive 3D content in their real environment. The content isn't static, it responds to what the learners do. This MR system guides the new hires step by step through driving and maneuverability courses. As the learners make decisions behind the wheel, the MR content responds in real time, providing feedback, adjusting guidance, and tracking their performance across the different learning sessions. Because the content is interactive and tied to the learner's actual inputs, this isn't a passive experience for any of them. The learners are developing real operator skills, not just watching a demonstration. And because every session runs through the same course with the same parameters, their performance is measurable and repeatable in a way that traditional on-the-job training simply can't match. So, there you have it. VR replaces your environment entirely. AR adds a digital layer on top of the real world, and MR is a blend of both, letting virtual objects interact physically with your actual surroundings and inputs. All three are genuinely powerful, and all three have a legitimate place in enterprise training. But the technology itself isn't a strategy. The most common and most expensive mistake we see organizations make in XR is choosing a modality before they've clearly defined the training problem. Hardware chosen because it looks impressive, rather than because it fits the need, leads to poor adoption and a very hard conversation about ROI. Because at the end of the day, the question should never be, what's the most exciting technology right now? The question should always be, what does this learner need to be able to do, and what's the best way to get them there? The right modality for the right problem. That's the only framework that actually has an impact. Now, there are a couple of paths forward in this framework. If you still have unanswered questions about your workforce's struggles, watch our training needs analysis videos next. We'll walk you through exactly how to identify and define a training problem before you spend a single dollar on a solution. Find the links to those in the description below. If you already know the details of your training problem, and you're trying to figure out if XR is the right methodology for a solution, keep learning with this video. We take a look at a variety of training situations and identify when XR works, when it doesn't, and why. If you have questions about XR training, leave a comment below, browse the rest of our YouTube channel, or read the blog on our website, roundtablelearning.com. Thank you for watching, and we'll see you in the next video.